Right, shall we start? Oh dear, feedback.
I think if we stand over here, it'll be fine.
Perhaps if we stand well away from each other as well.
So, hi, I'm Tim Ward.
I'm Holly Cummins.
So we've worked together for quite a long time, and we're here to talk to you about building modular applications with Enterprise OSGi. And I hope that, just quick straw poll, how many people here have used OSGi for anything at all before? Okay, that's pretty good. And we've got some people who've never used OSGi at all. How many of you know anything about what it does? Okay, this is good. I think we've got the level about right. So, I'll just start with a quick introduction. So, who am I? You can get hold of me on Twitter if you fancy. I'm a Java consultant at Sulka Engineering in the UK, and I spent 5 years before that working at IBM developing WebSphere, which is, as you, I'm sure, all know, an OSGi-based application server. I'm a project management committee member of Apache Aries, and I've done all kinds of stuff, but I really like digging around in bytecode, JPA, which has some bytecode stuff of its own, the OSGi blueprint, dependency injection in general, and lots of the enterprise good stuff that people know and love.
I'm Holly Cummins. My background is similar to Tim's, except that I'm still at IBM. And I've been at IBM for long enough that it's actually no longer polite to ask me how long I've been at IBM for. What I'm working on now is WebSphere and the Liberty Profile, but I've also worked in several other areas as well. I've done quite a lot of work on Java performance, and like Tim, I'm a committer on the Apache Aries project.
So, this is the quick pitch. So it turns out that, we've written a book about this sort of stuff. So if it turns out that you're interested, there are early access drafts available, and all of the chapters are done, and we really had hoped that there would be printed paper copies outside, but there aren't because it's not quite gone to press yet. It will be in the next week or so.
It was very sad. We got invited to do a signing at the bookshop, and I had to say, we would love to, but there's actually nothing quite for us to sign. But if you do go to Manning, we've got discount code later on in the slides, and you can get the ebook now, and then they mail out the printed copy to you once it's done.
So now that's out of the way, what we're going to talk about is what Enterprise OSGi is and what you might need it for, how you can use Enterprise OSGi in a WAR file, and how you would then build something called a WAB, and we'll get onto what that is later. How you can handle some third-party library dependencies, and then there'll be a demo of it all working fantastically well. So, what is Enterprise OSGi and why do I need it? Well, OSGi is mature technology. It's been around for, 11, 12 years at this point? Maybe even slightly longer, maybe more like 14 from the original JSR. And it's used in all kinds of places. So most people know that it's in Eclipse. Fewer people know that it's in embedded systems, home automation, Java-E servers.
If you happen to have Tim, if you happen to have a BMW 5 Series parked outside, which I know is probably a lot of the audience, it's got OSGi inside.
And if you happen to drive a Bombardier locomotive, that does too.
And if you've got that parked outside, please tell us so we can have a ride.
So Enterprise OSGi is a lot newer than the rest of OSGi. The first release of the specification was 2010, and its primary focus was to improve OSGi support for enterprise software. So OSGi had a really, really good foothold in sort of client side and also in embedded space, but for some reason in the server space, outside of the Java-E application server, it wasn't there so much. So the Enterprise OSGi specs, there are a lot of implementations. It's widely available across a lot of different app servers and open source, so you really can get this stuff wherever you prefer. So Enterprise OSGi, quite simply, is just OSGi applied to enterprise applications, which is, it sounds a bit silly, but for some reason people get really hung up on what does it mean. But what is an enterprise app? Well, we all have a pretty good feel for it, and it's the kind of thing that you probably weren't using OSGi to do before. So you have OSGi web applications, using databases within an OSGi framework, managed transactions, something that people really think of as kind of coming from maybe EJBs or Spring declarative transactions around Spring managed POJO, but not something you'd think in an OSGi framework. People normally think of it as being a much more low-level thing than that. So remote services are actually something that are reasonably new in OSGi and incredibly cool. And it's a sort of way of doing remoting that is transparent in such a fantastic way that you just would never have thought it possible in normal Java. But when it comes down to it, isn't this what Java EE is supposed to do? You know, isn't this why we use an application server in the first place? Why would we use OSGi? Why is it helpful? So, one of the main reasons to use OSGi is modularity. Now, we all write things that we call modules, and we say that our software is modular. But when you look at these things, are they really modular? Is that right? A big system is really hard to maintain because you've got to understand the relationships between all the bits of it. And I don't think that there are very many people who've written a war and really understand all of the dependencies that they have and all of the things that they're providing and what everyone else can depend on, not if it's a war of any meaningful size. So, anyone know what this picture is? Anyone at all? Most of you have probably used it. If you can see the text, which you're not really supposed to be able to, it's kind of the point, this is actually the Java EE API. It's not an application server, this is just the Java EE API. And it's that complicated. So if you think about an application that you write, it's really easy for it to look a lot worse than that because, you know, sometimes these applications, with the best will in the world, you go and design them well, but you don't have a huge number of people who have years of experience in architecting big scalable systems and have years to deliver each of these specs. What you've got is you've got a customer who wants that function and they want it in 2 weeks' time. So big applications, it's important to know, are just as complicated as the servers and usually have more dependencies than the servers do. So big WAR files, bigger than the servers they run on. And I use this to prove my point because Tomcat Core is a 7 meg zip file. Now, how many people have a WAR that is 7 meg or smaller as like the big project they work on? Not very many. I've been working with a client and their WAR file is 230 meg, which is actually then bigger than WebSphere, not Tomcat, bigger than WebSphere. So why are these WARs so big? Do I really need all the libraries that are in them? And why does Maven insist on putting the Java Mail API in WebInflib? I've never, ever been able to understand why so many web apps end up with that in there.
But what if you need it someday?
Yeah, but it's in the app server.
But what if you don't trust the one in the app server? What if you think 2 is better than 1 and 3 is better than 2? And to be really safe, I always find it's best to have 4 copies of a library.
Holly, it may sound like Holly's joking here. We have seen people who have 4 copies, at various points in the class path, but 4 copies of the same library, usually at different versions, just to make things particularly fun. So why can't my WAR be more dynamic? Do I really need to restart the whole thing to add a new payment type? We're supposed to be building these flexible systems that are easy to extend, but why can't we just extend them? Why do we have to completely redeploy? So, we were talking about versions just before. Have you ever found that you're using a library, but you depend on something which depends on something which needs version 1.2 of Commons Lang, and something else that needs 2.2 of Commons Lang, and you can't have them both at the same time? Well, in Java, you've got a flat class path. You're stuffed. There's nothing you can really do about that except try and find a different version of your dependency. And you can usually find something that works, but you'll have exactly 1 point release that you're allowed to use. And if you use anything else, the whole app stops working, and it's really brittle. OSGi is a bit different. So in OSGi, you have this class loader graph. So your jar may depend on A and B. Doesn't really matter what they are. But both A and B depend on C. but A needs C at version 1 and B needs C at version 2. So in Java, which is what you can see on the right-hand side of the picture, you've just got a stack where you've got your jar, you've got A, you've got B, you've got C at version 1, and that means A is happy and B is broken. In OSGi, because of the class loader graph, A and B can see different versions of C, and that's absolutely fine. So it suddenly frees up this system. You can actually just use the libraries you want. It all just works. So how can I do this? You know, we're talking about all of this great stuff. Surely it's really difficult to do. So actually, there are lots of application servers out there that you can run this on. So you are possibly using one that can do it already. WebSphere, Glassfish, JBoss, Geronimo, Karaf. You can use Virgo. You can use just the core Apache Aries runtime if you like. So that covers quite a lot of what people actually use. And most don't really need you to do much more than package as an OSGi bundle. There's this big perception that it's really hard to use OSGi, that it's really hard to move to OSGi, but actually it's not. An OSGi bundle is just a jar with a special manifest. So let's look in the manifest here. We've made it an OSGi bundle. That is actually all you have to do. Now this isn't a very good OSGi bundle, but it is an OSGi bundle. What will make it a better OSGi bundle is if we say, well, first, we should version of things, because versioning is quite important. You need to know what works with what other thing, and if the things aren't versioned, you've got no way of knowing. So here you can see we've defined a bundle manifest version and a bundle symbolic name. And that says what our bundle is called, and that in this case, it's running in an OSGi 4 or higher framework. Bundle version is just so we've got a nice version to refer to it. If we didn't put it there, actually the bundle would still have a version. It would just be 0.0.0, which isn't a great version. It doesn't tell you much about what it does. Also importantly, import package. This is a modularity statement. So the OSGi bundle we created couldn't see any packages that were outside it. It could only see the classes that were inside. So by adding this import package statement, we're saying that there are a couple of useful packages that we really want to use, so can we have them please? And the OSGi framework will make sure that those are available to you. You can also export a package, which is kind of the opposite of importing. This is saying, I make this package available to people for you to use. And that's really important because it allows you to define what your API is. You've got, fine in Java, you've got the concept of package private classes and maybe protected state, but actually people can still go and load those classes. People can pretend that they're in your package by just sticking another jar where they've compiled stuff into the same package and use it to expose whatever class you were trying to hide. And it doesn't stop people. OSGi does. OSGi says, you're making a firm statement about this API and I'm going to hold you to it and I'm going to prevent other people from breaking that assumption. So it's kind of a contract you have with the container. So I've been talking about jars here, but actually we're looking at wars. Isn't a war what we want to run? Well, wars and jars are really, really similar, but they are a little bit different, I'll grant you. So they've both got manifests, which is good for OSGi because the manifest is where all the metadata lives. But obviously jars don't have web descriptors. The classes go in a different place. Jar with nested libraries just doesn't really exist. I think you can write custom class loaders to do it, but hardly anyone does. And jars obviously don't have non-class path resources. The class path is the root of the jar. So there's a bit of a problem here. But it's actually very easy to solve. Because when the enterprise specs were being written, they knew that the lack of war support was pretty serious as a limitation. And there was something called the OSGi HTTP service, and there still is, but moving to that is non-trivial. If you have a war and you want to use the HTTP service, you have work to do, and it will take quite a long time to get it right. So what they did was they created the web application spec. And that's really simple, and it's support for something called a web application bundle. And it's important that they decided they were going to do the best they could to reuse what was out there. So it reuses all of the existing web deployment descriptors and their locations. And there was a firm requirement that it must be possible for something to be both a valid WAR and a valid WAB at the same time. Now, if you're a valid WAB, you don't have to be a valid WAR, but it is definitely possible to do that. So, first and foremost, Web Application Bundle is an OSGi bundle. It must specify the OSGi metadata. Secondly, it includes a Web Context Path header, and we'll say that this defines the context route that the WAB will be hosted at. And it also is there to say this is a WAB. Thirdly, if you want to use the standard WAR class path, you're going to need to set that up. Now there's a tool in OSGi to do that. It's called the bundle class path. And you can just say, my classes are in webinf classes, and I want to load this library jar from my webinf lib. And that's all you need to do. So we have our OSGi bundle from earlier. It's now a WAB. That's it. If we've got our classes in the normal WAR layout, then maybe we need to do that. But, you know, it's not difficult, this stuff. You know, we're done at this stage. Obviously, if you've just put the OSGi metadata into your WAR's manifest, then you may have migrated, but your WAR's the same sort of size as it was before. I mean, it's, if anything, slightly bigger because there's more data in the manifest. And you're not using any of OSGi's features. So this probably isn't what you're thinking counts as migration. And I think we would agree. I don't know that anyone would really say, oh yeah, I'm OSGi now at this stage. So remember the import package header? This allows you to move some of those jars that you had in webinflib out of your WAR. And you can also move out the things that they depended on. And this is really, really good because, you know, now your WAR's suddenly getting tiny because it's just the code you actually need. And a statement about the things that you depend on, but where those come from doesn't really matter. So, how do I develop and build a WAB? Holly?
Before I start talking about OSGi tools, I need to get into a bit of a dirty religious war. I think sometimes when people start looking at OSGi, they say, right, I want tools, because we all like tools are good. And so they look at what's available and they see a lot of tools and they think, well, this is a bit confusing. And the reason is that there's two schools of thought about how you should make OSGi bundles. The first is that tools can give you really good help with your manifest. So they can give you syntax highlighting, they can give you content assist, they can give you validation. And with all that, you can write a really good manifest. The second school of thought says, actually, no, I don't even want to know about my manifest. Tools just take care of it. And the reason for the difference, I think, has to do with how people think about manifests. So some people say, well, a manifest, it's a bit like Java code. You could get something to generate your Java code, but you probably wouldn't want to. And, you know, if you did, you'd have to go, you know, you do get the things where you drag the pictures and you get the Java code, and then usually you look at what it generated and you say, perhaps I'll change that, and I'll change that, and ooh, I wasn't expecting that. You know, Java code is something that's so important to the execution of the program that you want to see it, you want to write it, you want to have control over it. You maybe don't want to write it all in VI, but you know, you do want to know what's there. The second school of thought says, actually no, a manifest is more like the Java bytecode. It's something that can be generated from what you already have. You don't need to know what's in there. Writing it is boring, so let's just not write it. I think both ways of doing it have a lot of good points. What you do, it partly depends how lazy you are, to be honest. It depends if you're the sort of person who, you know, when you get your car, you like looking under the hood and seeing what's going on, or whether you're the sort of person who says, look, just make it all work. But I think it's also a bit like, you know, when we were in school and we learned mathematics, you know, they didn't give us a calculator straight away, did they? They said, well, you know, you have to learn to add 2 plus 2 before you can type 2 plus 2 into the calculator, because you need to understand what's going on. You need to know what a good manifest looks like so that you can look at your manifest when everything is going wrong, even if a tool generated it for you, and see why it's not doing what you expected. So if you want to do the manifest first approach, the best tool for the job really is Eclipse PDE, which is the Eclipse plugin development environment. It's a little bit sad when you use PDE. Everywhere it says plugin, if you just mentally substitute bundle, it's a great set of tools. if you don't do that, then you look and you think, why is it talking about plugins? I don't want to write plugins, I want to write bundles. But if you ignore that, it works really, really well. And then for build, you can use plain old Ant, because you've got your manifest written already, so all you need to do is just compile it, build it up into a jar, same as you would normally. If you want to take advantage of what Eclipse has already done for you, of how, the class path that Eclipse has generated for you, but you want to use Maven, you can use a plugin to Maven called Maven Tico, and that's really quite cool. It gives you all the class path enforcement that Eclipse does for you, but in Maven. And if you look at an example Tico Maven file, all of the plugin dependencies or the POM dependencies that you would normally have in your Maven file aren't there because Tico reads them from Eclipse, so it works quite well. And what I've got on the screen here is just a few examples from Eclipse. So you can see on the left there I've got the manifest editor. At the top I've got a GUI editor of the manifest, and it gives you quite a lot of help in working out your package imports as well. So I've got that. If you want to do code-first development, well, in terms of IDE, one of the great things about code-first development is you don't actually have to choose an IDE that knows anything about OSGi at all. So you can use your preferred IDE. If you really do want to have tooling support all through your toolchain, then you can use Eclipse and B&D tools. But this is really sort of a frill on top. It's not actually necessary. For build, however, you will want build tools that are OSGi aware, but you don't have to look very far at all to find them. So if you're using Maven, if you just choose a bundle packaging rather than a jar packaging, it will all just work. If you want to then tweak your manifest, you can also do that with some configuration to the Maven bundle plugin, but it really is very painless to get it going.
Absolutely.
And I didn't put a line on the slides because it was clutter, but if you're determined to use Ant as well, you can invoke B&D from Ant, and then you can do all the same things as you would normally do for your Ant build. There are also some tools that have specific awareness of enterprise OSGi. So they know about all the things that enterprise OSGi can do. They give you editors for some of the extra files and extra things that you might want to do with enterprise OSGi. One tool for this is Eclipse Libra, which is it's sort of intended to work agnostically across all the enterprise OSGi runtimes. There's also, IBM has one, IBM is contributing to Libra, but IBM also has one called the OSGi Application Development Tools. And they can all just be downloaded from the Eclipse marketplace. And what I'll be showing you and what I'll be using is the OSGi Application Development Tools, but it's not. You could actually use Libra, or you could use another tool of your choice if you wanted to. It's not vital what tool you're using. So one thing that trips a lot of people up when they first start using OSGi is they say, I'm going to use OSGi, I'm going to modularize everything, it's going to be fantastic. And then they get to their first dependency, and they go, oh, now what do I do? Handling third-party libraries, it can sometimes be a bit tricky. So there's a few options. The first option, which is something that people often don't realize, is that the jar that you think is causing a problem for you may actually already be a bundle. Because remember, a bundle is just a jar. So if your bundle has OSGi metadata in it, then you're good to go. So it is worth cracking open the jar and looking inside the manifest, and you may be pleasantly surprised by what you see.
And that does cover almost everything in Maven Central. And then there are loads of places where you would download your stuff, and it is already an OSGi bundle. So we can't say this enough. Look inside, check, because you'll save yourself a lot of effort.
Yeah, we see on Stack Overflow, fairly regularly, someone will put a question and they say, oh, I need an OSGi version of this library, and people will come back and say that library actually is an OSGi bundle already. A second thing to think about is that even if the version of the library you're using now isn't an OSGi bundle, a newer version may be a bundle, because lots of people are moving in this direction, so they're adding support, and more support comes every day. So if you upgrade, you may find you're okay. The third thing that you can think about doing, these are in descending order of goodness and preference, is you may find that someone's already done the work for you to convert this library into an OSGi bundle. If it's any kind of popular library, if it's not already OSGi, someone somewhere will have converted it. There's a few places to look, and I'll come back to that. The next thing you could do is you could consider actually using an alternative library. If you think, this library that I'm using, that I think is so great, they haven't converted it to OSGi, and no one else has bothered to convert it to OSGi. Do I really need what it's doing, or is something somewhere else doing the same thing better in a more modern and more maintained way?
And if they're not prepared to accept your request to make it an OSGi bundle, then do you really want to keep using this library that they're not, maintaining properly and
not responding to the community?
Yeah.
And the last thing that you can do is you can wrap your own bundle. And we've got this last on the list, which makes it seem like a really terrible thing and only a last resort. But it is actually very, very easy to wrap your own bundle. So even though it's the last resort, it's easy. Actually, I should have clarified, that was the second last resort. The absolute last resort you can do is you can embed the jar into your bundle. So, Tim showed in a war, you've got the WebInf lib. You can put anything you like into there.
But why?
Yeah, if you do that, you do lose a lot of the modularity advantages of OSGi, and your war that was supposed to be small and lean has just become large and flabby again. So it's not ideal, but it is an option. So you shouldn't let third-party libraries be a barrier to using OSGi. So if you need to go look for OSGi-fied bundles, there's a few places you can look. SpringSource have what they've called an enterprise bundle repository, and there's loads of libraries there. There are also loads on Maven Central. So if the original publishers of a library haven't made an OSGi version available, often someone else has made an OSGi version available. And the trick to finding it is that the artifact ID will be the same, but the group ID will be different. And so if you look for those, you can find them, and then you see all of the differences that one's a bundle and one's not. If you need to wrap bundles, it's a one-line job. So if you download BND, which is the tool that drives the code first development I was talking about before, and it's also embedded into the Maven bundle plugin. If you just point BND at your jar and say go, it will turn your jar into what's called sum.bar. And I think this took both of us by surprise because we expected it to produce sum.jar, but it doesn't want to overwrite your jar for obvious reasons. And it can't call it anything else because the correct extension is jar. So it calls it sum.bar, and then you never find it again. But now you know. Look for sum.bar. And the way it does the conversion is it tries to make a bundle that behaves as much as possible like the original jar. So every class inside the bundle is externally visible. And every dependency that jar has is optional. So that means it shows all its internals to the world, and it doesn't have any hard dependencies on anything else. So this means it's definitely going to work, it's definitely going to start, you're definitely going to be able to use it. It's not really taking advantage of what OSGi does for you, so you may wish to adjust these defaults, which you can do just by providing a properties file to BND. And you can make it just feel a little bit more like OSGi and put a little bit more error checking in terms of what it needs from its environment.
Yeah, you can find that if you do leave all of your dependencies as optional, that you end up with this little problem where actually you can install and start your bundle before you've installed any of the rest of the runtime. And that's not always a problem, but it can be, because if it did have any hard startup dependencies that it really needed, when you load this class, if its superclass isn't available, things are going to go bang. And that's not something that you get any checking for if you make all of the imports optional. So just be careful if you start relying on the defaults, because it'll give you a warm fuzzy feeling in your test environment when stuff's always installed in this order, and then you go into a kind of UAT environment and install it in a different order, and it won't work, and you won't know why.
So the last option is to embed jars. And this can be a good option if you get some of the more subtle problems with a wrapped jar that can sometimes happen. So if your jar does some really weird things in terms of its class path and how it does reflection and how it does class loading, you may find that it needs internal surgery to work in an OSGi environment. And if that happens, you can just put it into your bundle and it's more or less guaranteed to work. You share the same class space with the third-party jar, so there's no class visibility issues. But of course, it does. If everybody does that, then you get quite a lot of bloat, and you lose some of the advantages of OSGi. So you can do it if you need to. It's best avoided. So one more thing, we didn't want to try and cover the whole of OSGi in 55 minutes, because probably we'd run out of time, your heads would explode, no one would be happy. But I didn't feel right leaving these slides without mentioning one of the other really great features of OSGi. So the first great feature of OSGi is the modularity it gives you. It gives you this understanding of what your dependencies are. It gives you a language to express your dependencies and have those dependencies enforced. And it gives you a really clean separation of your class path, which gives you performance advantages and just cleanness advantages. The second really great advantage of OSGi is what's called OSGi services. They're sometimes also called microservices. And they give you just a fabulous dynamism and a fabulous way of integrating your application together. We've all heard of the factory pattern, right? And we've all been trying to use the factory pattern. And when I first read about the factory pattern, I thought, well, this is great. It's going to be loose coupling, fabulous, no hard dependencies. And then I tried to write something that used the factory pattern, and I realized I had to write all this reflective class loading in order to actually eliminate the class loading. And what I had was not clean and not nice. And I think pretty much we've been trying to solve the factory pattern ever since. And none of our solutions are really very good. So the first thing we did was reflective class loading. And then, we've done meta-inf services. And we've tried to do things where, you just say new initial context, and under the covers, magic is happening to try and bind that to a specific initial context implementation. And it's all pretty dirty. It's all not very nice. Most of it is very static. So if you want to change what implementation gets loaded, before your application starts, you've got maybe some chance of doing that. After your application starts, if you want to swap out for a different implementation, there's no hope.
Actually, yeah, if you ever fancy a challenge, try and change the JNDI provider for a running web app. I give you maybe 3 years, some research money, and you probably still won't get there.
And so what OSGi services allow you to do is exactly what you want to do with the factory pattern, which is say, I would like something that implements this interface, please give it to me. So OSGi provides a service registry, everything lives in there. Unlike a lot of solutions to the factory pattern, it's 100% dynamic, so your services, you can swap out the implementations. One caution about OSGi services, and I think maybe one of the reasons that the whole room isn't using them right now, is that the API can be a bit fiddly to get right. Because they are so dynamic, you need to put in lots of error checking, and then your application has a hard dependency to OSGi. And a lot of what we've been talking about so far has been the fact that you can use OSGi without having these hard dependencies to OSGi, because a bundle is just a jar. Another question that we see on Stack Overflow is, how can I convert my bundle to a jar? To which the answer is, your bundle is a jar. If you're using services, you lose some of that. So a much better option is to use dependency injection. So there's several dependency injection frameworks that operate off OSGi services. So if you're in an OSGi environment, your services get injected quite cleanly, quite nicely. If you're doing unit tests, or if you're running outside an OSGi environment, you can just swap out your dependency injection framework. So the first of these is Blueprint, and it's one that Tim and I are very fond of because we've helped write the implementation. Another very popular one is Declarative Services. There are some others available as well. So if you're using Google Juice, there's an OSGi service version of that, which is called pberry. And there's also, iPojo. Thank you. So certainly one of these you'll find very useful.
Yeah. And when we're saying don't use the API directly, as Holly says, there are some ways in which it could be a bit cleaner, but it's not so much that the API is bad, it's more that writing the code to cope with the hugely multi-threaded environment with dynamic dependencies coming and going all over the place is just a nightmare. We sat down and we wrote something which, so handling one service dependency is okay. Handling two, where you need both of them to be available at the same time, we had a class that was, 300 lines long? And it wasn't doing anything other than keeping track of those two dependencies. And that's why we would say don't use the API directly. It's not that it's a problem, it's just that if you want to use more than one service, you will have a much, much easier life if you use dependency injection.
Yeah, and again, because OSGi is dynamic, you can do things with the dependency injection, and the dependency injection does things for you that normal dependency injection doesn't. So you can express, I've got this service, and for this service to be available, I'd like these two services, and those two services have other dependencies. And if one at the very back goes away because you stopped it, then it very neatly unregisters everything down the chain, so your system doesn't get left in an inconsistent state. But enough about services. We said, we're just scratching the surface. If you would like to know more, there's plenty of resources available. So what we're going to do now is a demo. Were any of you in my quickie talk yesterday? One or two. I have to say I'm very glad it wasn't more of you. I gave a demo and I managed to unplug the power from my Raspberry Pi. And so then I tried to connect a web server to it, and funnily enough, my unpowered Raspberry Pi wasn't very responsive. So I've got a bit of a sort of a post-traumatic stress demo fear now. So maybe the demo will work with a bit of luck or with quite a lot of luck. So we'll go into the demo with low expectations. So what I'm going to start off with is just a fairly ordinary war. So I've got a dependency on Joda time. I was so disappointed when I discovered that Joda time wasn't pronounced Yoda time, but life is full of small disappointments. In a realistic war, of course, I'd have a lot more dependencies. My lib folder would be stuffed to the gills with dependencies. I tried to keep it simple, so I've just got Joda time. I've got just a war manifest here, and then I've got just a few little classes. And what I'd like to do is I'd like to convert it to an OSGi bundle. And I'm using Eclipse PDE, so it's going to give me a lot of help with this conversion. So I've got here the manifest editor. So I'm just going to open my manifest. If I go to my overview, it's giving me a bit of help already. It's saying an OSGi bundle, unlike a normal jar, it has to have a symbolic name. So I'm going to call it block stacker. And I'm going to call it version 1.0. And then my red X's have gone away. I'm converting a war to a WAB. So I'd like to do something a bit special with my class path so that I'm still using the normal war class path. And so to do that, I'm going to go here. I'm going to add webinf classes to my class path. And I'm also going to add the Joda time jar directly. So I'm getting there now. And you can see in the console at the bottom, all this scrolling is that I've got it running on WebSphere Liberty, and so it's, restarting my application.
How many people here have actually seen Liberty running before? How many people have used WebSphere and don't really believe those deployment times? Yeah.
You see, what we've done actually is we've got an asynchronous process in the background running on a server, and it's got a little time machine inside it. So when it detects that I'm about to redeploy my application. It sends it back in time to the mainframe server, which runs it distributed across 10 servers. It recompiles it, redeploys it, and then sends it back to the future and to me. And that 0.21 seconds is the ping time to my server running back in time. It's very clever technology. It's times like this that you regret recorded presentations, because when my boss sees I said that. So the last thing I'm going to do is I'm going to import some packages. And this is where we really start to see the difference between an OSGi bundle and a WAR. Because, of course, with a normal jar, you don't have to import anything. And I think the first time you see this, you think, well, this is such a pain. I did have something that's working, and now I'm having to do all these extra steps, and I'm having to import packages. But this is actually a really good thing, because what I'm able to do here is, as the developer of this WAR, I know what the dependencies are. Eclipse also knows what the dependencies are, and it can tell me. But if I give it to Tim, and I ask Tim to run it, if I don't give him any information about what the dependencies are, he's going to maybe have to try and read the Java doc, try to work out what the class path is, try to figure out a good environment in which to run it, and it's a hard work. So it's quite good to actually make this explicit. It gives you an error checking. So because this is a servlet, I'm going to add some JavaX servlet packages, and I've got a JSP, so I'm going to add those as well. And I'm just going to add one more thing as well, and the reasons for this will become clear in a moment, which is JavaX naming. So now, with this, I'm nearly there. And I've got one last thing to do, which is if I go to my manifest, it says web bundles must define the web context path header. So this is a piece of information that I put into my manifest to let OSGi know that this is a WAR or a WAB, and that I'd really like it to be available on the web. So if I do web, whoops, put it up here, web, if I go back to my content assist, thank you. I have a theory of typing ability in demos, which is that your typing ability just is inversely proportional to the number of people watching. And so when there's a hyphen involved, your ability to get the hyphen into the right place, no matter how many times you've typed it before, is about nil.
The other wonderful thing about the demo gremlins is that your typing ability is inversely proportional to how well the demo is going.
Right, so now I'm going to take my life in my hands now, and I'm going to see if this all works. So I've got my JSP. I'm going to say run on server, and it is actually already running on the server, but that was just laziness to get it to bring up the URL. And it's working, so that the first hurdle has been done. And you can see this time here is the time that's coming from Joda time, and that is dynamically updating, which is reassuring. So now I'd like to try something else. What I've done so far is just the sort of the first step of converting it from a WAR to a WAB. I've got it exactly the same as it was before, but with some additional metadata. And I've still got this Joda time in my lib directory. And I really want to get that out of my lib directory. So I'm just going to delete that. Yeah, I really do want to delete it. And I still want to delete it. So then, you can see now, if I go to my time displayer, I've got some red X's. So Eclipse has told me, well, you've got this dependency on Joda time, but you have no Joda time. So what I'll do is I'll go to my manifest, and I'll add in some Joda time libraries. Joda time is one of those bundles that's a jar and a bundle both, which you may not have known. Unfortunately, it's not very well modularized, so you do need to import a few packages in order for it to work. Whereas a very clean modularization, obviously, you'd only import the API and everything would work, and everything else is internal to Joda time. So if I go back to my time displayer now, you can see I'm using Joda time, and it's all just working. Because I've got that import, I'm good to go. So now, if you look in the console, you can see I've got a problem. An exception was generated when trying to resolve the contents of the application. I've got a dependency on org.jodatime, and it's not resolved. So I think this is one of the few times when giving a demo and you see a stack trace, and it's such a happy thing. It's a happy thing because I was expecting it, but it's also a happy thing because it means it's working. My dependency management is doing its job for me. I've ripped jodatime out of my war, and I'm trying to run it in an environment that doesn't have jodatime, and it's not working. And it's so much better in this situation to fail fast, to fail before I even try and start that bundle, rather than to get 2 weeks into production and then we go down some code path that we didn't go down very often, we try and display the time, and we get a class def not found exception. Because those sorts of things can be really difficult to find in testing. And so if you get them all up front, you know before you've even got out the door that you've got a problem. So that's great. So what I'm going to do now is I'm going to add a bundle repository to my server. And this is one of the other really good things that the explicit dependencies give you, is if you know what you depend on, then you can go somewhere else and you can drag it down. You don't have to package it all around for you. And you can have a bundle repository, and it can automatically bring in your dependencies for you. So you can see in my server back there, I've got a jodatime jar just in a folder, and I only put it there so it was somewhere convenient within Eclipse. It's not actually going to use that. So I'm going to go to my servers view. I'm going to open my server configuration. And I'm going to say what I'd like is a new bundle repository. And I'm going to add a new file set. And I'm going to say in users/holly/bundle.repository, I'd like it to pick up everything in there. And so now, maybe, nope. So let me just restart my application, because there we are. So now I've got my application running again. And you can see that this bundle repository, it's a really powerful thing. In a way, it's as powerful as a Maven repository, because I've got just one on my laptop. But it could be, somewhere else. It could be pulling things in from somewhere else. This bundle repository only has jodatime in it, which makes it a sort of small and sad and lonely bundle repository. But it could have a lot more in it. And, I can put every jar my application and my company might ever need to know about in it, and then they can just get pulled into the application as required.
And the good thing about doing that is it means that you can actually look at the stuff that is going to be in your applications. There are all these companies, and this is going to sound a bit more DevOps than DevOps, but all these companies that are really strict about what libraries you can actually use. And they've got all of these huge processes for just trying to stop you doing it, whereas all they really need is their own bundle repository, and you can't get anything from anywhere else. You're never going to start using it because you'll just get the one from the bundle repository. It's a really nice way of doing development.
So what I've been doing so far is I've been running my application on Liberty, the WebSphere Liberty profile, just because it's a server I know well. But now I'm going to try something different, and I'm going to run it on a different server. And normally, if you have the same application that's going to run on 2 different servers, that's when you get extra paranoid and defensive about putting everything you could possibly need in your lib directory. Because WebSphere, it's sort of an industrial strength server. It does have a lot of APIs available, but not all servers do. How many of you have heard of Karaf? Yeah, about a third. Karaf, it's sort of one level up from a basic OSGi runtime. But it's a really nice, elegant runtime environment. It's got a way of installing features into it, so it comes as just the bare metal, and then you can add things into it. But it is very much a minimal environment. So I certainly, I couldn't trust anything to be there. So what I'm going to do is I'm going to install my little application into it. So I'm going to install it as a file, and then I'm going to go to the web. Oops. And once again, I get an error. And this is because I haven't started my bundle. So unlike normal jars, bundles have a life cycle, so you can stop and start them as well as installing them. So this makes them much more dynamic. So I'm going to start 110. I'm going to try again, and it's going to work, depressingly. So now is when. So, any explanation for why it's working?
Well, I can see Joda time in there.
Yeah, it's uninstalled though, so that's a bit sad.
Have you refreshed packages?
I haven't refreshed packages. So I'm going to just quit Karaf. I'm going to start again. And there we go, that's what I was expecting to see. This is the peril of practicing your demo before the demo, is you leave it in a state that you weren't quite expecting. So it can't use my little war because I haven't got Joda time. And so if I go here, no Joda time. So now I can install Joda time. So I'm just going to install it. And now,
still not started.
I'm going to start my bundle. Thank you. And we've got time. So now what I'm going to do is I'm going to go one better. So far what I've had, as you've seen, it's been fairly static. So either my package dependency is there or isn't there. If it's not there, my bundle's not started and I have to manually start it. If I had my package dependency and then it went away, my application might still be started because I forgot to do the incantations. But of course, one of the real advantages of OSGi is it gives you so much more dynamism, and that's where the services come in. So in here, you can see I had a sneaky other class that got a reference to a service. And it was doing it by a sort of a hybrid bridge approach. So it looks it up in JNDI with this OSGi service namespace. And then it's looking up something with this interface. And if it finds it, it does something. So far, I haven't got any of those. And so nothing happens. But if I install something that provides that service, and I start it, and then I go back to the web, hey, I've got a service. So I've got much more dynamism in my web app than I normally would have, but I can do better than that because I can stop it now because I've decided I don't like the blue rectangle, and blue rectangle gone. And then start it again. Sorry, I think there's probably a finite number of times I can do that, but I just think it's so cool that you get that kind of dynamics. And, if I had multiple implementations, I could have multiple rectangles. It's so cool. Any time you need to do dynamic rectangles on a web page, OSGi, it's the way to do it. So I think with that, I'll leave it there. Leave it there. And we'll go back to... I think that was a fairly disaster-free demo. I am impressed. Yeah. Obviously, I worked out all my demo bad luck yesterday. So just a sort of a, this is where the gremlins are.
Yeah. Serves us right.
Yeah.
Last-minute edits.
Yeah. So I think, sometimes people say of OSGi that it makes really, really incredibly difficult things quite easy, like that dynamism that we were seeing, and it makes easy things hard. Perhaps we're biased because we're both really dedicated to OSGi, but I'd say OSGi makes impossible things really easy and easy things really easy. So it's a very cool technology. And modularity and dynamism, they give you so much power to enforce good architecture. But they can only enforce good architecture. They can't do it for you. So you do still need to work with what it's given you.
Definitely.
So finally, this is a bit of a eye test, and you'll do well to copy all this down, but we've got here, they will be on the recorded version, some useful resources for you. If you did want to know more, the code for Manning is EOSGi 37. And there's also quite a few other Manning books on OSGi, and they're outside on the bookstore, and we would recommend them. So OSGi in Action is a great general introduction to OSGi. And OSGi in depth then goes into some of the corners as well and gives you quite a lot of useful information.
Yeah.
And Developer Works is also a great place to find OSGi resources.
Yeah.
So, anything else? Yeah. Oh, slide transition. So, any questions? I think we've got about 2 minutes left. Yeah.
Oh, one at the front.
If you have a big application with hundreds of dependencies, do you have to go to your WebSphere administrator and say, when you load this application, you also have to load these hundreds of services, or is there some automation?
So the question there was, if you've got a large application with a lot of dependencies, then how do you cope when it comes time to deploy it? Do you have to deploy 100 things, or is it just sort of one that can be automated?
So one way of doing this is Enterprise OSGi gives you what's called an EBA. And so that's sort of an equivalent to an ear. So it does allow you to have a higher level of granularity. So if you know that 90 of those 100 bundles you're just going to want to carry with you all the time, then you can put those in your EBA. The other thing you can do is you can deploy them to a bundle repository, and then you can say, right, when my application gets deployed, it's going to have these dependencies, but I'm not going to handle them because I've got them pre-deployed.
Yeah.
Does that answer your question? Yeah.
So they can be referred to by reference in your EBA. So they don't need to be deployed up front, and it's a single deployment step like it would be with an ear. You need to make sure that those bundles are available somewhere. So whether that's packaged actually in the EBA or packaged in a bundle repository somewhere, but those bundles would only need to be deployed once, because typically these dependencies are going to be libraries.
That somewhere can be, for instance, Nexus?
Yes.
Yeah, I think we're out of time, and I'm aware that we're the last talk of the conference, so I think we'd probably better let you go. But I did see one or two more questions, so if you want to just come up and have a chat with us,
Yep.
that would be great.